Hi everyone, how are you all doing? Hi everyone. Yeah, I can see that a lot of people are waiting. Thanks a lot. Arvind Menon, hi. Sumit Shah, hi. Rishika K, hi. You need to data science. Okay, that's good to know. Gilbert, hi Gilbert. Hi Megha Bharatidasan. Hi Sumit Shah. Okay, so we'll wait for a few minutes so that everybody can join. Hi Siva, how are you doing? Hi Rachit. Okay, so there's something special today for you guys. So I appreciate your time here with me in this live session. So in this live session, all the live attendees, they'll be getting access to some handy cheat sheets where they're very useful, especially if you're a beginner, then it'll help you learn a lot. And then I'll also give you some project ideas. Based on that, you can get started. Hi, Yogesh. How are you doing? Okay, so I think I'll get started with the introduction. So as I told, you'll be getting access to some very good handy cheat sheets of Python, pandas, regex, scikit-learn, and its algorithms, and then even about data science. So coming to data science, so the data science cheat sheet which I'll share with you, it'll give you an overview of probability and statistics, machine learning, deep learning. It'll also compare different machine learning models, and then even big data, SQL, and all those. And then I have another cheat sheet called scikit-learn algorithms. So many of them want to get started with machine learning, and they have the data. They want to apply their model for the analysis and predictions, but most of them don't know which model to choose. Thanks to the research, there are so many models now given for the same problem. So I'll be sharing the cheat sheet based on the number of rows in your data, then whether you're predicting a category or quantity, and whether you have labeled data or not. It will suggest you the right model you can use for the prediction. And then just say for some reason that model doesn't work, it also provides alternatives. Okay, so there's another cheat sheet called Pandas. So if you're new to Pandas, because Pandas is very important tool for data science. So you'll be able to learn the series and data frame, data structure, and then how to read and write to CSV files, Excel files, or how do you read and write from an SQL query or a database table. And then you'll also learn how to deal with missing values, how to deal with duplicate values, and then how do you group rows or features based on certain characteristics. Then you'll also know how to deal with dates, how do you do visualization with pandas, and so on. And then the regex cheat sheet covers. So if you don't know what is regex, so regex is a very important library for string matching, especially in text analysis, text mining, or natural language processing. This cheat sheet will help you learn a lot. So coming to this cheat sheet, it will help you understand the character classes, the grouping based on characters, the groups, rules, and then how can you match a particular string based on the parameters and the structure of the string. And then there's another cheat sheet of Python. So if you're like transitioning into data science or you're new to programming or Python, because Python is a very important programming language for data science, so you should be 100% familiar with it. So let's say even if you're coding and then somewhere you mistype the syntax and you got an error, so you need not search on Google every time. So you can refer to this cheat sheet and then use them, and it will be very helpful. Yeah. And then the second bonus thing, which all the live attendees for surely get, is I will help you start in with some projects. So I'll give you some project ideas, and I'll also give you the data sets, and I'll tell how to get started with the project, what kind of questions can be answered, which methods to use, and then how the whole process works. So it can be hard for people to get started, especially if you're a data science beginner or fresher or who's just transitioning. So what I do is first, I'll explain some solutions for few problems based on that data set itself. And then you can come up with your own problems on the data set, and then you can work on them based on what you understand from my teaching. Oh, I'm sorry if the video is lagging. Can you refresh your browser? Yes, the projects will be very helpful for beginners, and don't worry, I'll start from the scratch so that you don't get any doubts, and then you can go on with your learning. Okay, so I think we'll get started. Okay, so first I'll explain some things you can do with pandas. So let me share my screen here. Yeah, I hope that you're able to see my screen. Yeah, okay, so let's get started. So missing values is a very big problem in machine learning. So some of the models are clever in getting rid of these missing values on their own, but few models will throw an error when there are missing values. So what you have to do is you have to deal with it. So there are two ways. So first you can drop the missing values, or you can do the imputation of missing values, where you substitute missing values with a parameter which doesn't have the value as nan or not a number. Okay, so you decide that I don't want to drop all the columns in my data set. So let's say we set a threshold of 70%. So only if a column has greater than or equal to 70% of missing values, only then we'll drop them. So here we can declare a variable called threshold with a value of zero point 0.7, which is a fraction. And then you can use pandas, the power of Boolean indexing. So here when you use data.columns here, so you'll get the list of all the columns. And then when you do data.isNull, you'll get all the null values. And then you can use the mean method to see the proportion of missing values in that column. And if it's less than the threshold, you can assign it to the data variable. So essentially you're overriding it. Did you all understand? Okay, so also I will be giving you some time for questions and answers. So at few particular timestamps after I explain few concepts, you can throw in your questions, and I'll more than be happy to answer them. Okay, so now we're done with the columns. So let's say rows have missing values. So you can use the same concept here, but instead of using data.columns, you have to use data.log, because that is how you access rows. You access columns using data.column, and then you use the same principle. So you do data.isNull. So you'll get the output of true or false. If it's a missing value, you'll get an output of true. If it's not a missing value, you'll get an output of false. And then you can take the mean. So here I've specified the axis as 1, which means it will sum along the column. So if it's less than the threshold, we can reassign it to the data variable. Okay, so this is how you deal with missing values. But let's say we have a very small data set, and the number of rows or the data we have is very important. So at no cost, we want to reduce the size of the data. So in that case, what you can do is you can replace missing values with some values. So a very popular and common throughout the whole data science industry is you replace that value with 0. So let's say, so you have data, and then you can use the fill NA method, where NA stands for not a number. So in the parameter you supply as the argument by which should the null values be substituted. And then you can also substitute the missing values with the medians of the column. So I would say prefer median over mean if your data has a lot of outliers, because uh, if there are outliers, then your mean is going to increase a lot, and that doesn't reflect the distribution of the data that you have. So median is susceptible to outliers. So I would say prefer median over mean if there are a lot of outliers. Then you can use the same fill NA method, and in the argument, instead of 0 in the previous case, you can use data.median. So data.median returns the median of all the columns, and then all the null values in the data frame will be substituted with the median values. Okay, this is how we deal with numerical values. Yeah, you can get access. You can get access to this video after the live session. It will be uploaded on YouTube. but I highly recommend stay with me in this live session, because there'll be some interaction between us. Then you can get your questions answered if you have anything about this and in general about data science. Okay. Now, let's say that your column has categorical values. So they're not numerical. So let's say a column has values Paris, Madrid, Italy, Spain, and so on. So these are categorical values, right? That is, they're taking discrete values for that column. So what you can do is you can replace all the missing values in that column with the maximum label. So let's say Paris appears twice, and then Madrid appears thrice, and then all the missing values can be substituted with Madrid, because that has been occurred the maximum number of times in that column. Again, you can use the fill any method, but you have to do a bit of lengthy procedure here. So you have to select data of column, that is the name of the column in which you're dealing with. And then you have to use the value counts method. So when you use the value counts method, you will get the count of each of the value in that column. And then when you do max, you will get that value which has appeared the maximum number of times in that column. And then here we say in place equals true, because here we are not assigning whatever the operation we are doing to the data variable. So in place equals true ensures that we replace our existing data frame. Basically, we are overwriting it. Understood? Yes, this is pandas. And then I'll also go into some machine learning, and then how you can visualize and how you can build the best models from your problem, then how to choose a machine learning model for your problem. So first, we'll do with pandas, because pandas is very important for data science. And this is where you do all the data pre-processing and data analysis steps in the data science industry. And then one thing, how you deal with categorical values is you use a label encoder. So scikit-learn has a method for this, so you need not implement your own function. So what you can do is from sklearn, you import the pre-processing module. And then from pre-processing, you call the label encoder. So LE will be the instance of the label encoder object. Then let's say the data we have in a column is 1, 2, 2, and 6 as shown here. So for the label encoder to be applied on this data, we have to use the fit method. So use le.fit and then supply this data. And then when you use a classes underscore attribute, you'll get the output of the label encoder. That is what classes has the label encoder identified. So here, if you see 2 has repeated twice, but in the classes output, you can see that there's only 1 to 6 because it takes only unique values. And then let's say you have some new data. So 1126, it's different from a previous data, right? So and then you can use the le.transform method on this data. So here 1 will have index of 0, 2 will have an index of 1, 6 will have an index of 2. So 1 will be replaced with 0 because the index of 1 is 0. So that is how label encoder works. And then the index of 2 here in the classes list is 1. And then the index of 6 is 2. So this is the transformation of the data via the label encoder. What you can do is there's also a method where you can reverse this procedure. And obviously this method is called as the inverse transform. So let's say to prove that inverse transform is the inverse of transform, we will take this data itself as the input. So if we take 0, 0, 1, 2, so for the index 0, what is the value of the class? So here for index 0, it's 1. So you'll get 1, 1, 2, 6. So here you can see that inverse transform is the inverse of transform. So this is label encoder and how you deal with categorical variables. But there's another method called one-hot encoding, which is much better than this. And then I'll explain that soon. Okay, so here you can see that whenever you deal with categorical variables, the number of columns of the output will be equal to the number of different categories of the column. So here we have 1, 2, 6. So those are 3, right? And then even in the classes output, you can see that there's 1, 2, and 6. So the number of columns, that is 1, 2, 6, 3, is equal to the number of categories the column can take. Yeah, now coming to one-hot encoding. Okay, yeah. So let's say the data is a multi-dimensional array. So it's an array of arrays. So male comma 1, female comma 3, female comma 2. So as before, you have to create an instance of the one-hot encoder module. So you can take that from sklearn or pre-processing. So here we have created an instance of the one-hot encoder object. Then we have to use the fit method so that one-hot encoding is actually applied. And then instead of the classes underscore, you have to use categories underscore so that you will get the classes or the categories that one-hot encoder has understood from this data. Okay, so because in a single array there are two values, so in the categories also we'll have two arrays. So one for male and female, so that is just taking the unique values, and then the other for 1, 3, 2. So here you can see that female male is here, then 1, 2, 3 is here. So the data type is object, and then so let's say there's some new data, and then you want to apply this one-hot encoder on that data. Then you can use the dot transform method. So let's say our data is female 1, male 4. So from here we can see that female has an index of 0, male will have an index of 1. 1 will have an index of 0, 2 will have index of 1, 3 will have index of 2. So when you use a transform method, since female is 0, here the first thing you'll get is 1, and then 0, 1, 0, 0. Okay. And then for male, because it is 0, 1, so male will be 1 here. And then since 4 doesn't appear in this 1, 2, 3 array, all the values will be replaced by 0. And then here there is 1. The index of 1 is 0. So at index 0, there will be a value of 1. So as we saw in the previous case, here also we have a method called inverse transform, which will take the inverse of the transform that we just did with the one-hot encoder on the data. And then, outliers are possible. So in the data set. So what do we call as outliers? So let's say we have the data as 1, 3, 7, 9, and then suddenly 100. So 100 is an outlier, right? Because it is far from the actual or the normal distribution of the data. Identifying outliers is a very important step, because if you don't identify the outliers, then you won't understand the predictions. So let's say you don't identify the outliers and 100 was included in the analysis. So your data will be a bit skewed, which doesn't actually represent the distribution of the data. So how we detect outliers is that using standard deviation, you can detect outliers. So let's say there is a value called X and the mean is M, standard deviation is sigma. So if the distance between the value and the mean is greater than some factor times the standard deviation, we can classify it as outlier. Now you'll get a question as what should this factor be? Unusual value is between 2 and 4. So I'll take the value of the factor as 3, and then I'll show you how you can drop the rows with outliers using the standard deviation method. Okay, so for that, you first define the upper limit and lower limit. So what is upper limit? Upper limit is the mean plus the factor times standard deviation, because that's the maximum, the upper bound. Then the lower limit will be mean minus the factor times standard deviation. So if the data of the column is less than the upper limit and is greater than the lower limit, then we take only that value. So here we are using this as the index into data. Then we are overwriting it using data. There is another method called z-score. So z-score is basically you take the mean of all the values, the standard deviation of all the values, you apply this operation called the value minus mean whole divided by the standard deviation. So using this, you can normalize your data. Okay, and then you can also identify outliers using percentiles. So let's say we define outliers as the 95, all the values above the 95th percentile and all the values below the 5th percentile. So here again, we can define the upper limit and the lower limit. And then we can accordingly say if the value of the column is less than the upper limit and is greater than the lower limit, take only those values. So the upper limit can be defined as everything above the 95th percentile. So you can use the quantile method in pandas. Okay, so you understood until here, right? Okay, so you might have an obvious question. So whether should I drop the missing values or I should substitute the missing values? So I say if you have very less data, so let's say you have 1,000 rows and you have like 500 rows with missing values. So I would say instead of dropping, you substitute the missing values with some values, because if you drop 500 out of 1,000, you're potentially losing 50% of the data. And in today's world, data is very valuable. Okay, so let's say you have a million rows and then only 1,000 rows have missing values. So if you don't want to deal with the imputation and you don't care much about the data, you can safely drop it, because 1 million is such a huge scale, and then you're getting rid of only 1,000 out of a million. So here we have defined the upper limit and lower limit using the percentiles as I told about. So if the value of the column is greater than the upper limit, and then in that column, so replace that with upper limit. So in this way, we are capping all the values to the upper limit. If the value of the column is less than the lower limit, then what you do is you substitute that with the lower limit. Okay, and then one another procedure in data pre-processing and data analysis is called as binning. So where you group values into a discrete set of categories based on some criteria or a characterization of the data. So when you do binning, you potentially sacrifice some amount of data, but it's always a good procedure if you have a lot of data. So here, let's say that we have values from 0 to 100. And then we want to bin it based on this criteria. So we say if the value is between 0 and 15, label it as low. If it's between 16 and 80, label it as medium. If it's between 81 and 100, label it as high. So this is numerical binning. And then here you can see BMW, Mercedes-Benz, Hershey's, Mars. So this is the categorical binning. So first I'll walk you through the numerical binning and then the categorical binning. And then one another important thing to consider is if the frequency of certain values in the categorical column is very less, then I would say group all of those together into, let's say, a category named other. Because if the frequency of a particular value in the categorical column is very less, it can skew the model's predictions. So an example here is, so let's say you have 1 lakh rows in your data set, and if the frequency of a particular value in the categorical column is less than 100, then you can group all of those into a category called other. Okay, now numerical binning. So pandas provides a function, so you don't have to do anything, just have to use this function. The name of the function is cut. So you use panda.cut, then you supply the data. So let's say value is the column, and then data of value will actually give all the values of the column. And then using the bins parameter, here we define the edges. So when you think of it as a histogram, so let's say if you have 4 edges, then you'll get 3 categories. So the first category will be between 0 and 15. That is using the 2 edges. And then the second category will be between 15 and 80. The third category will be between 80 and 100. And then we specify the labels. So what should the data between 0 and 15 be called as? So here it's low. And then, so we assign all of this operation into a new column called bin inside our data frame. And then let's say you give a value of 12. When you see the category of 12, it will be low because it's between 0 and 15. Then 8 will also have a category of low because it's between 0 and 15. 90 will have high, 28 will have mid. So that was numerical binning. So it was very simple, right? So now let's see categorical binning. For this, first you need to define conditions. So it will be an array, and then so data of items. So let's say items is the name of the column for which you're doing this particular analysis. And then you can use .str.contains to say if BMW is contained, or if BMW is present in the particular value. That's the first condition. Then the second is if Mercedes-Benz is present. The third is Hershey's, fourth is Mars. And then you define an array of choices. That is, after I convert these into bins, what should the labels be? So here, since BMW is a car, I give it the first thing will be a car. And then Mercedes-Benz is a car, so the second value will be car. Then Hershey's and Mars are chocolates, so the third and fourth values will be chocolates. And then I define a new column called category in my data frame. Then I use the select method from NumPy model. So here NP stands for NumPy. The first parameter or argument will be the list of conditions we specified. So here, and then the second will be choices, that's the labels. And then here default is other. So let's say the value is something like Ferrari, which is not present here, right? Because here we only have BMW, Mercedes, Hershey's, and Mars. So when it is binned, the label to that, instead of being given as car or chocolate, we'll give it as other because it was not in our conditions. Yeah, I will give you the cheat sheets in some time. So stick with me. I'll first explain everything so that you get an understanding. And then when I give you the cheat sheets, you'll be able to use them accordingly. 15, just a second. Let me check again. 15 will come under low category. So everything between 0 and 15, including the lower and upper bound. So here, if you see, I told that between 0 and 15 is low, and then 16 to 80 is medium, 81 to 100 is high. I hope you understood that. Yeah, 0 to 15 is first category. Yeah, Rutraj, you're correct. Yeah, data.log is for rows and data.ilog is also for rows. So using data.log, you have to supply the label or the name rather than the index. If you use the ilog method, then you can supply the index of the row. So there are two. Yeah, I will give you all the notes. I'll share it at the end. So please explain binning. Nilam says explain binning. Okay, so let me explain binning. Okay, binning, right? So in binning, we basically categorize the values. So let's say we have the values from 0 to 100. We want to divide all this value into three categories. So we want 0 to 15 as low, 16 to 80 as medium, 81 to 100 as high. So we can use the cut method in pandas to divide all the values between 0 and 100 to just three categories. We will be sacrificing some amount of information in the binning procedure, but it's very important in data pre-processing. I hope you understood that. Okay, so the next method is something called as log transform. Okay, so where you transform using log. So log transform is a very important method if there are outliers or if the data is skewed. So log transform will basically normalize all the data. Okay, so let me give an example here. So let's say data is a data frame with values 245 minus 23 and so on. And then when you need to apply log transform, all of the values need to be positive because log of negative or zero is undefined. So what we do is, so before using this dot transform of np.log, we do data of value plus one. So just to make sure everything is non-negative. And then so here we have a negative value. So minus 23, minus 12. So how do you handle negative values? So here there's a method called, so if you subtract value, a particular value from the minimum of all the values and then add one, it will definitely be a number greater than one. Because let's say we're dealing with minus 23. So if a particular value is negative, the minimum of all those values will be negative because minus 23 minimum or something less than minus 23, which again is a negative number. So when you do a negative number minus a negative number minus, a higher negative number, you'll get a positive number. And then, so let's say if the minimum is that itself, minus 23 plus 23 will become 0. So you add 1 just to make sure it's non-zero. Okay, so we already did one hot encoding, right? Just a second. Okay, yeah, here I have an example. Let me explain it with an example. Okay, so in the column, if we have data like user 1, 2, and then 1, 3, 2, 1, 1. And then the city is Roma, Madrid, Istanbul, and then Roma. So when you use one hot encoding, it will be converted like this. So the city column will be replaced by two columns of Istanbul and Madrid. So here we have three distinct values, that is Roma, Madrid, and Istanbul. The reason I selected only two here, as you can see here, is because Roma can be thought of as where the Istanbul's value is 0 and the Madrid's value is 0, that signifies Roma. So if you have n distinct values, then it's enough to map them to n minus 1 binary columns, because the remaining column can be mapped as or thought of as where all the values are 0. And again, there's a handy method in pandas which is called as get dummies. So use pd.getDummies, where pd stands for pandas, and then you use data of column. Then basically the data of which you need to get the dummies for. That will be stored in encoded columns. So since we want encoded columns in a data frame, you can use the join method where encoded columns will be joined with our existing data. Then here we're dropping the original column, because once the city column has been converted into Istanbul and Madrid, we no longer need city column because all the information is already preserved in Istanbul and Madrid. Okay, and then it's grouping. So first, categorical grouping. So what we do is, so let's say ID is the column we want to group by, and then use AGG stands for aggregation. Then here we map a lambda function here. So if you don't know what is lambda function is basically used to write functions in just one line. So you can use x dot value counts. So this actually means for the column, get the counts of each of the values in that column, and then dot index of 0. So we are basically taking the first value of it. So here, if you see, there's a column called visit days. So Roma is 1. So for the first user, visit days for at Roma is 1. And then at Roma is 3 here. So 3 plus 1 is 4. So here we see 4. Then the user one has gone to Madrid once. So here in Madrid we see 1. And then user one has gone to Istanbul thrice. So there'll be a value of 3 here. So this is how categorical grouping works. So you're basically converting two columns, city and visit days, into the number of columns as the categories in the city column. Uh, Positive or both? Sorry, Siva, I didn't understand what is deals with positive or both. Can you clarify? Do you mean positive or negative? So data of log plus one. The reason we add one to the value is to make sure that it's non-zero, because log of zero or log of negative number is undefined. Okay, and then the next topic we'll go into is called as pivot table. So here, I mean, there's a handy function in pandas called pivot table. So for that, we need to give five things. The first is the index. So the what is the index for that data frame, and then what are the list of columns, and then what should be the values in those columns. Agfunc stands for what aggregation function should I use to determine the values for those columns. So let's say we get a value which has not been encoded yet, then we can replace it with 0. That's what field value says. Okay. Okay, now we'll come with a feature split. So let's say there's a column called name, so data.name, and then we will split by white space. So here in the parameter, you can just see there's an empty quotes, which means it's an empty space. Then you use map, so you can map a lambda function to this. So to the name column, we are mapping a lambda function. So when you use str.split of white space, you get all the objects separated by a white space. So here we are telling x of 0. So we're just taking the first thing before the white space. So feature split. So that is how it works. And then let's say we have another column called title, and the data is in parentheses. So what we want to do is we want to get only the data that is inside the parentheses. So instead of giving white spaces, we can give an empty or an opening parenthesis. And then when n is 1, we say just split once based on this. And then expand equals true means we need it in two separate columns. And then for this, again, we do dot str dot split of the closing bracket. Again, we say n equals 1 because we only want to search for this closing bracket once, and then we expand it and then get the 0th value. So it's basically the first value. Okay. So the next thing is scaling. So scaling is a procedure used to bring down all the values in a particular column to the same range. The first method in scaling is normalization. So in normalization, what we do is, so we take a particular value, subtract the minimum from that value, and divide it by the difference between max and min. So here you can see data of value minus the minimum of the value, and then divided by the max of the value minus min of the value. So in this way, all the values will be between 0 and 1. There is another procedure called standardization here. So which stands for standardized. I'm creating that column in the data frame. So for that, what you do is you subtract mean from that particular value and divide it by standard deviation. Okay, now we'll see how to handle with dates. Okay, so from date time, we'll import the date module and then we'll create a data frame. So this is how we create a data frame in pandas. We use pd.data frame, and then the name of the column is date, and then the values that the column should have is this, which is supplied in an array. So it's Jan 1st, 2018, and so on and on. So here we're just defining the date column. Now, when you define it, because we are not explicitly stating that it's a date data type, so we're just saying that the name of the column is date, but pandas, no one knows that the type of this data is date. So by default, the data type will be strings. So now we need to convert string into the date format. So there's a handy method called toDateTime in pandas. So the first argument will be the date column. Then we tell in what format is the data. So %d means date, hyphen, %m means month, hyphen, %y means year. So we say it's in the format of day, month, year. And then let's say out of all this data, we just want to extract the year. So from data of date, so that is from the date column, here, if you see that we can use dt. So dt is nothing but the shortcut for date. So we use dt.year to access only the year. If you want to access only the month, you can use dt.month. And let's say you want to know how many years or months have passed by since that date. So what you can do is if you do date.today, you'll get today's date. But we need only the number of years here as told. So again, we'll use the year attribute here. Then we'll do minus. From that date column or the value, again, we can use dt dot here. So here we can extract that values here. Here we can extract the current year. So by taking the difference, you will know how many years have passed by that particular date. Let's say you want to know how many months have passed by that particular date. So what you can do is if it's greater than 12 months, you can take the difference in years, multiply it by 12, then you'll get the number of months. And then you can add the today's month, subtract from the month of that particular data. So here you'll get the number of months that have passed. Let's say we want to extract the name of the date. So let's say that there is 12, but it's Monday. So we want that particular output. So there's a handy function called dt.dayname in pandas. So for that value, you can just use this and then you get the name of the day. Okay, so that's it. We're done with this. So first we'll solve some problems, okay, in data science or using pandas. Okay, just a second. Let me share my screen here. Okay, are you able to see my screen here? Okay, so I have Olympics data set. Okay, so I'll explain you what the data contains. So it has the number of summer games played by a country, number of summer medals won, number of winter games played, number of winter medals, the total number of games played, the total number of medals obtained. Okay, so we need to use this data set to answer some particular questions. Okay, first thing is to get in the data. We will import pandas as PD. Okay, then we can use the read CSV method and then pass in the name of the data set. So olympics.csv is the name of the data set, and then the first column contains the list of all countries. So we want the index of the data to be the name of the countries. So we say index call equals 0 means the first column has to be the index. We say skip rows equals 1, which means we need to skip the first row. Okay, let me just show you the data once. Okay, so this is just some data pre-processing. You don't need to know this. Okay, so this is how the data looks. So we have each country here: Afghanistan, Algeria, Argentina, and so on. Here, number of summer games, number of gold medals in summer games, silver medals in summer games, bronze medal in summer games, and then the total number of medals in summer games, the number of winter games played, the number of gold, silver, and bronze medals in winter games, the total number of winter medals, the total number of games played, and then here is the ID, which is just a three-letter abbreviation for the name of the country. Then here combined total is the sum of the medals won in the Summer Olympics and Winter Olympics. Okay, we have the first question here. What is the first country in our data frame? So this is very simple. So the first country means we actually need to get the first row from our data. To get rows, there's a method called ilog. So you can use ilog and then supply the index as 0, then you'll get the first data. So here we can see the details of the first data. So here Afghanistan is the first country in our data. So as we previously saw here. Okay. The second question is, which country has won the most gold medals in summer games? Okay, most gold medals means the maximum value. So the more gold medals in summer games stands for the gold column. So we can do df of gold dot max, then we'll get the maximum value out of all the values in the gold column. And then we see at which position or which value is equal to the maximum value. And then we can use that as the index into our data frame. And then since we want the country, then country is the index in our data frame. So we access the index first, then you'll get the actual index and the data type, but we only need the country. Then we use values, and then we just need the first one. So we'll index it by 0. So here the answer is United States. Okay. Are you able to see the screen now? Are you able to see the screen or the data? Let me know in the comments. Are you able to see the screen here? Is it clear? Yeah, okay. Then let me continue. Okay, the next question is, which country had the biggest difference between the summer and winter gold medals? Okay, so here we are seeing biggest difference. So what we do is the summer gold medal is in the gold column, and then the gold medal won in the winter games is in gold dot one column. So what we do is we just take the difference here. Okay, then here it says the biggest difference. So we just take the max of it. So out of all the possible differences, what is the maximum difference possible? Now we need the name of the country which has this largest difference. So here I've said the max value has the largest difference. So I will take the difference between these two columns in the whole data frame. And then I say, where is it equal to the maximum value? And then get that particular index it as 0 because we only need the first name. Okay, done. In that way you can get. Okay, now the next question is, Okay, now the next question is, which country has the biggest difference between their summer gold medal counts and winter gold medal counts relative to their total gold medal count? Okay, so here what we need to compute is summer gold minus winter gold by total gold. Okay, and then here it's also said that only include countries that have won at least one gold in both summer and winter. Okay, summer gold is gold column. The winter gold is gold at one column. So at least one means greater than or equal to one. So we can use this condition and then index into the data frame called df. Okay, so the first condition is df of gold should be greater than or equal to 1, and the second condition is df of gold dot 1 should be greater than or equal to 1. So this is for summer gold and winter gold. Then we add or combine both of these conditions using the ampersand parameter. Okay, now again we take the difference between those and then divide by, so total gold is present in gold dot 2 column. So we take the difference and divide by gold dot 2. So this is the metric. So now we have the values for this computation of all the rows. Now we say at which position is it equal to the max of that particular value, and then go to the index, get that particular value, and we just need the first value. So here the answer turns out to be Bulgaria. Okay, the next question is, we have to create a series called points, which is a weighted value where each gold medal, that is gold dot 2 column, counts for 3 points, silver medals, the silver dot 2 column for 2 points, and bronze medals or bronze dot 2 column for 1 point, where the country names as indices. So this is very simple. So what we can do is, so 3 for the gold dot 2 column. So we can just do 3 times gold dot 2 column plus. So here weighted value means we have to add each of the weights. Then 2 times silver dot 2 column. So 2 times silver dot 2 column, and then 1. So that just means bronze dot 2 column. And here we'll name it as points. So because here we are told that we need to create the series named points. That is the reason. Okay, now the next data set I have is from the United States Census Bureau. So this data set contains population data for counties and states in the US from 2010 to 2015. Okay, first we read in the data. The name of the data set is census.csv. We use the read CSV method in pandas, then read in this. So we can use the head method so to just see the first 5 rows in the data. So here we have, oh, we have 5 rows and then 100 columns here, okay? We need not go into depth of each of the column. So, okay, let me just give an overview of it. So sum left stands for summary level. So it takes in 2 values, 40 and 50. If the data is for a county, then the value of sum level will be 50. If the data is of a state, sum level will be 40. Then region is a categorical variable. Division is the same, state is the same, and then there's county, state name, county name, and then the population in each of the years from 2010 to 2015. And then what was the census value, okay? Let's just get into the questions, okay? Which state has the most counties in it? The name of our data set is census df. Okay, census df that group by. So here we need to group all the values by state. Only then we will know for which particular state is the count of the counties the maximum. So first we can use the group by method and supply in the state as the argument, because we need to group by the state column. And then most counties, so what we can do is for each state we can sum the, not sum, sorry, we can count the number of times there is county. So for that we can take the county name dot count. So this first line basically gives how many counties are present in each state. Now we need to find the maximum of it. So this is series. So we index in as where is series equal to the maximum of series, and then dot index of 0. We're getting the index here because we need the name of the state. And then when you group by state, the index will become state instead of the country as it was originally. And then we check, so state, where is the state equal to this particular index? So this index is where it was maximum. And then we need the name of the state. So be clear that state column has only the ID of the state, but not the name of the state. So we need to access that using the state name column. And then because you'll get so many values, we need only one answer. So here I'm saying up to one. So this is basically slicing in pandas. And then I say dot values, get the values from that. Country of zero gives basically the first one. And then here the answer is Texas. Okay, the next question is, only looking at the three most populous counties for each state, we need to determine the most populous states in the order of highest population to lowest population. So basically in the descending order. And here we are told that we need to use Sense 2010 pop column. Okay. Since we need counties, I had earlier given a hint saying that if summary level is 50, then it means that the data is for counties. So what we can do is the first step is get all the rows where the summary level is 50. Okay, done. Now we need to group by the state name because we need to know the most populous counties for each state. So when we group by the name of the state will become the index. So in that way, it will be easier for the analysis. We are told that use census 2010 pop. So we access that column. Now here they're telling that we need the top three. Okay. So we sort all the values in the descending order and then we take the top three. So we can apply a lambda function using the apply method here saying that x dot n largest of 3 because we only need the top 3 and then sum them because only by summing will we know the sum of all the counties population for each state. And then we need to get the 3 largest states. Okay, then get the index, get the values from the index and convert it into a list. So this is not mandatory. I'm just converting into a list because lists are like the default data structure in Python for usual analysis. So here the data we get is California, Texas, and Illinois. Okay. Okay, the next question we have is, which county has had the largest absolute change in population within the period 2010 to 2015? Here they have also given us a hint that the population values are stored in pop estimate 2010 to pop estimate 2015 columns, and we have to use all the 6 columns. Here we need to find the largest absolute change. So what we can do is first find the largest change, take the absolute of it, and then done. So here there's an example. So if this is the data, then the largest difference will be between the maximum of all the values and the minimum of all the values. So what we have to do is first we will extract the maximum for all these columns. So here we are told okay, so here we need to consider only for the counties. So here we say sumlev equals 50. So in that way, we get the information only of the counties. Then we supply the name of the columns. So that is pop estimate 2010, 11, 12, 13, 14, 15. Okay, so this is the max, okay? So we need to use the max method and supply axis as 1. So axis as 1 means consider it as column wise. We are telling pandas that way. And then we need to extract the minimum. So we repeat the same thing again. So instead of max, we just use the min method. Then we just take the difference between both of these columns. Okay, so max, min. So just take the difference and store it in diff. Now, where is this difference equal to the maximum difference? Because we need the largest absolute change. So we compare the maximum value out of all of those with each of those values, and then use dot ilog of 0 to get the first row. And since we need the name of the county, we access the county name or CTY name. So the answer turns out to be Harris County. Okay, the next question is, we need to create a query that finds the counties that belong to regions 1 or 2, whose name starts with Washington and whose pop estimate 2015 was greater than pop estimate to 2014. This function should return a data frame with 2 columns and same index. Okay, so this question, they're asking that we need the name of all the counties which start with Washington, whose pop estimate 2015 was greater than pop estimate 2014, which belong to regions either 1 or 2. And then when we get all this data, we need only 2 columns, that is the state name and the county name, and the index ID should remain the same. So the region information is stored in the region column. We can just say where is census of region is equal to 1 or is uh, identified with the pipe operator like this. So it's 1 or 2. So again, one region 1 or region 2, and the county name should start with Washington. So the county names are available in CTY name. Then we can use str.starts with Washington. So starts with is the method. It identifies whether a particular value starts with Washington. And then there's another condition that pop estimate 2015 should be greater than 2014. So census DF pop is greater than 2014. And then here we need all the rows. So here we specify just the colon before the comma, which says we need all the rows, but we need only two columns. So we specify the names of the columns here. And then here in the output, if you see, the county name is only starting with Washington. Okay, so here we finished all the examples. Now, just a second. Okay, now I'll give you an introduction to machine learning. So now we are done with pandas. Okay, the next thing is introduction to machine learning. So here also we'll use a data set and then identify or solve the problems in the same way, because solving problems will help you to apply your skills and understand how these skills are used and for which question should I use a particular skill, okay, or the method. Okay, coming to the next part, there's a simple classification task. So we are given the data of fruits, and then we need to classify which fruit it is. So this is a fruit classification problem. So first we're importing all the necessary modules. So NumPy, Matplotlib, Pandas, and then train test split, because I'll go into the details of each of these later. First, we are just importing all of this. Now we have to read in the data. So the name of our data set is fruit data with colors.txt. And since it's a table, we use the read table instead of read CSV. And it's stored in fruit. So fruits is the data frame containing our data. And when you use the head method, so here you can see the sample data. The first column is index, then here there is fruit label, and then the fruit name, the subtype of the fruit, mass, width, height, the color score, and so on. So, so here is the criteria how color score was assigned. So if the color was red, I'm sorry, if the color was red, the data is between 0.85 and 1. If it's between 0.75 and 0.85, then it's orange. If it's between 0.65 and 75, then it's yellow. If it's between 0.45 and 65, then it's a green color. So based on these, the colors were assigned. So here we have the data set, okay? First, we'll create a dictionary because we need a relationship between the label of the fruit and the name of the fruit. So the reason there is a column called fruit label, because machine learning models deal with numbers, right? So let's say I just have the fruit name column where it's an apple, mandarin, and it's in words. So the model will not be able to understand the words. Okay. We will create a mapping from the fruit label value, which will make the results to be interpreted easily. So first, we need to combine both of these columns. We can do that using the zip function in pandas. And then since the values have been repeated, we need only the unique values. So from the fruits data set, go to the fruit label column and take only the unique values. And then we need to combine that with the fruit name column. So go to the fruits data frame, take the fruit name column, then take only the unique values. So here we have zipped both of them. Now we want to create a dictionary. So to create a dictionary out of the zipping, so just use the dict and then pass in the argument as a zip. So here, after doing this, we can see the output as if the fruit label, sorry, if the fruit value is 1, then it's apple. If it's 2, then it's mandarin. And if it's 3, then it's orange. If it's 4, then it's lemon. Let's first examine the data to get an understanding of how is the data, how is the data distributed. So first thing is this, that's called as data analysis or data pre-processing. Humans are very good at understanding visuals rather than numbers. So first we'll start with visualizations. We'll plot a scatter matrix. Okay, we need x, y. In the fruit classification problem, the target or the label we want to predict is the name of the fruit. The name of the fruit is stored in the fruit label column. So we will take only that column as y. Then all the remaining columns, height, width, mass, color score, as x. So we will use x as the data to build our model, and then y is the output of the model. So you can think of it like that. In any machine learning model, we have to split the data into two sets, one for training and the other for testing. The training data set is used to train the model, the testing data set is used to test the model. So we need not write our own function or do anything. We can just use the function provided by scikit-learn. So the name of the function is train test split, and then the input will be x, y, and then random state. Okay, so here you can see that random state is 0. Random state is given because when you execute the code again, you don't want to get a different output. So to make the code reproducible, we use a random state with a particular value. So every time you run this particular line with random state as 0, you'll get the same output no matter what. Now we want to get the color map, or CMap. So you can think of color map as the color scheme which will be used to plot a data. So GNU plot is the name of the color map, which is very popular in Linux, and it's a portable command line driven graphing utility, and it's very common. It was initially developed for scientists and students, but it became widespread and popular very quickly. So we can use the get CMap method and specify the name of the CMap we want, and then we'll get that. Then from the pandas.plotting, we can use the scatter matrix function. So this basically or plots a scatter plot between each of the columns, and the first value should be x train. So that is height, width, mass, color score. And then the color of our data should change based on y train. Then the marker used to denote the values will be a 0 or a circle shape. S stands for size of this marker or the circle, which is 40. And then we can specify the number of bins we want as 15. And then the figure size. So 9,9 means the size of the figure should be 9 inches wide and 9 inches high. And then the color map is set to CMap, so which we had obtained earlier using the get CMap function. You can see the output here. Okay, so here height, width, mass, color score in the y-axis. Here also height, width, mass, and color score. So here you can see that in the okay, so there are 4 columns, right? So it's a 4 by 4 plot. So in total there will be 16 squares or 16 grids. If the plot between the same name of the column, let's say between height and height, will be a histogram. So that was the reason we specified the number of bins as 15. So here the second column is width, as you can see here. So height and width. So here we can understand that there are 4 different colors because we have 4 different fruits, as you saw: apple, mandarin, orange, and lemon. So here at just the first glance, you can understand that the purple shaded one is easily separated out, and the gray and brown ones are always together. So we can understand that there's a high correlation between the brown colored and the gray colored fruits, and then the yellow colored and the purple colored ones are a bit far apart. Now, this was just a 2D visualization. CM means color map. CM stands for color map. Yeah, it's same like pair plot. Yeah, correct. Okay, now let's plot a 3D scatter plot, and this will be much more visually pleasing for us. Okay, from MPL toolkits.mplot3d, we will import the Axis 3D module. First, we'll define a figure. Here, PLT stat is the short form for matplotlib.pyplot. So here, if you see above, we had imported matplotlib.pyplot as PLT. So that is PLT. So we can create a figure using this, and then we will add a subplot. So subplot basically means you can have a number of plots in a particular figure. In our case, we will be having only one figure. So that is the reason all are one. Okay, so here are the three ones, which means the first one means we need only one row. Second one means we need only one column. The third one means this is the first entry in this row and column. We set the projection as 3D because we need a 3D plot. Then since we need a scatter 3D plot, we again, using this axis, we use the scatter method. So let's say we want to plot a scatter plot between width, height, and color score. So the first argument will be width column, then the height column, then color score column. So, and then how should the color of the data change? It should change based on white rain. So C has been set to white rain. Marker is 0, means we need circles to represent the data. S, or the size of the circle, should be 100. Then we'll add labels. So set X label, you can set the label for X axis, which is the width, because that is the first thing here. Then we can set the Y label, Z label similarly, which is height and color score respectively. So here, if you see, there's a beautiful plot which is much visually pleasing than the 2D plot. And here you can understand how the color score varies based on width and height. So here, for example, if you see that if the color score is greater than or equal to zero point 0.7, then there's a high probability that it's a purple colored fruit. Okay. Now we're done with visualization. So what we have to do is, now we have to create a train test split, that is split the data into training and testing. So we will take the features as mass, width, and height. So we will assign that to X. And then the target we want to predict is the name of the fruit, or the label. So by default, train test split creates 75% of the data as the training data, 25% of the data as the testing data. Then we set a random state equals 0 for the reproducibility of the code. So we'll get 4 values here. The training input, testing input, training output, testing output. Now we want to create a classifier object. So we will use a k-neighbors classifier machine learning model. So we can import that module from sklearn.neighbors. So if you don't already know how k-neighbors classifier works, so k-neighbors classifier works based on the voting procedure. So all the neighbors near a particular point will vote. So that is, their label will be considered. I'll get into the details soon. So here we say that we need 5 neighbors for a prediction. Then we can use the fit method to fit the data to the k-neighbors classifier object. So here knn is an instance of k-neighbors classifier object. We can fit using the training input and the training output. And then if you want to know the accuracy of a model, we can use the score method, then supply the testing input and the testing output. So here we see that the accuracy is just 53%, which is not very good. So I'll get into the next steps of how we can improvise this to get a better accuracy. Okay, now that we have built a model, so let's say we get future data of mass, width, and height, then how can you predict using this model? So we can use the predict method, and then the input will be the list of the values. So here, 20 grams is the mass, 4.3 centimeters is the width of the fruit, 5.5 centimeter is the height of the fruit. So you supply this, then you'll get fruit prediction. Because it's gonna output a number starting from 1 to 4, so we will index it into lookup fruit name. So as we had earlier created a dictionary, which was a mapping between the fruit value and the fruit label, so you can actually get the name of the fruit for a particular value. Now let's try one more. So this would be a larger elongated fruit. The previous one was a small fruit because the mass was low, width and height were also low. This will be a larger one than an elongated fruit, which means its height will be much greater than the width. Okay, we use the predict method. And then here we supply 100 grams, 6.3 centimeter width, 8.5 centimeters height. And then here we see that the lemon is a prediction that our model has made. Now let's plot the decision boundaries of a k-name classifier. So here we see the output. So I'll explain the code of how to plot this. So first, just understand the plot. On x-axis, we have height. On y-axis, we have width. So this plot basically differentiates between different categories. So here we can see red color is apple. So the red circles indicate the actual data. And then the light red background indicates that, let's say, if we give any other circle or data value in the red region, then it will be classified as apple. Then the same thing goes to mandarin, green color, orange in blue color, lemon in gray color. Okay. The reason I use KNN because that is very good for classification, and there are different ways of explaining how the behavior of the model will change based on the number of neighbors it is. So you can also try this with different models. So that's the reason initially I told I will be explaining you, and then I'll be sharing with you the code and the data files. You can implement different models or some better models based on whatever you think. And you can use the score method to predict the accuracy and see how the accuracy changes for the same data set based on different models. Okay, so here we will plot the decision boundaries of the k nearest neighbors classifier. Okay, first the inputs it'll take is the x, y, number of neighbors, and weights. So in k nearest neighbors, what you can do is by default it gives uniform or equal weightage for each of the neighbor. You can also give high proportion to the neighbors near the data value so that they have more influence than the ones which are far above. So we'll just use height and width from X, and then we'll convert both of these into matrices. And then we'll define two color maps. One is the light color map for the region, so that was in the light shaded background. But then the bold one will be for the actual circles of the data values. So this is red, green, blue, silver. This is light red, light green, light blue, and then silver. Again, here I'm initializing the k-neighbors classifier with number of neighbors as what was supplied to me, and then weights as weights, where weights is what was supplied to the function. And then we use the fit method and fit it. Now we go a bit into plotting. So first we need to create a mesh grid. And then to create a mesh grid basically converts coordinate vectors into coordinate arrays. So we want to go from xmin to xmax, and then we give the step size. So here I'm giving the step size as 0.01 so that we know the nitty gritty details of the plot. So if the step size is small, we'll get to know all the details better. And then xmin, okay. So xmax is the data. Then we can use dot min -1 because indexing starts from 0. And then dot max +1 for that column, and then we'll get xmin and xmax. That is for the first column. And then how to get ymin and ymax is change the column. So here we told for the 0th column, but now we need for the first column or the second column if the indexing starts from 0. So now we have the minimum and maximum values for both the x-axis and y-axis. We can use np.arange function to go from the minimum to maximum with the step size as defined here as 0.01, comma, and then we also need to go along y-axis, right? So we specify both x and y inside np.meshGrid. So you'll get two things as the output. So that is the x-axis values and the y-axis values. Then we can use the classifier, the predict method, and then here there's something called as np.c underscore. I will explain that in a moment, just a second. I'm not sure how long the lecture will last because there is so much information to cover. If you want, I can stop it here, or if you want, I can continue, and then I'll share the cheat sheets and the project ideas. What do you want me to do? Okay, then now I'll share. Yeah, tell me, Shivan. Okay, continue. Okay, a lot of them say continue. Okay, okay. I'll continue. Okay. So when we do a mesh grid, so we don't actually get them as a 1D array. When we use the ravel method on both x6 and yy, will convert it into a one-dimensional array. So the value is in a single row or single column. Then np.c underscore, you can think of this as the concatenation operator. So for prediction, we need two values, right? The first should be height, the second should be width. When you concatenate, so you'll get the first value from xx, the second value from yy. So this will be repeated for all of the values. And then you'll use the predict method on this. The predictions will be in z. Then we want the shape of the output to be same as the shape of the input. So we'll use the reshape method of the output, that is z, then specify in the argument as the shape of the input. So the input or the x-axis values is xx. Now we'll initialize the figure, and then p color mesh stands for the actual plot we're doing. So that is with different colors. So first x-axis, y-axis, and the predictions we made, and then what should be the color map or the color scheme used for this plot. Now we have plotted the decision boundaries. Now we need to plot the actual circles or the training points. So for that, we'll do a scatter plot, okay? So to get all the rows on just the first column, we index it by 0. Then all the columns, and then all the rows in the second column, that is height and width. And then the size should be plot symbol size, which is 50 here. C is Y because C tells how should the color of the values change. So it should change based on the target, right? Only then we will get a clear distinction of how the data has been separated into different categories. Then the color map we use is CMap bold because those are the dark colors for the circles. And then we say edge color as black. That is, all the circles should have a boundary of black color. We set the limits of x-axis and y-axis using xlim and ylim. So the minimum limit will be xx.min, which we had earlier computed. The upper bound will be xx.max. The same thing we do for the y-axis also. Okay, now we have made the plot. We need a legend. So otherwise, how will you know which color means which category? By default, you can create legends in default using matplotlib. But if you want to give more customization, or if you have more than two values, then you have to use something called as mpatches here. Okay. So we use mpatches.patch, and then apple should be in red color, mandarin should be in green color, orange in blue color, lemon in silver color. So using mpatches.patch, we create 4 patches here. Then to convert these patches into a legend, we use the handles method, handles argument here, and then the value for that will be the array of all the patches we just created. Now we will give the labels for x-axis and y-axis. So in x-axis, since we have height, in y-axis we have width, so we will name them accordingly. plt.show is used to see the actual figure. So this was just the definition of the function. So we didn't call the function. So here I'm calling the function with x train, y train, then 5 neighbors, and then uniform weighting. Okay, so let me explain how this actually works. Okay, 5 neighbors, right? Let's take this blue point, okay? Tell me the 5 nearest neighbors to that. So it's gonna be this, 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 and this. And what is a majority? So all of these 5 were of silver. So that is the reason blue colored training point was predicted as silver. So k-neighbors classifier works based on the knowledge or the data label given by the neighbors. So I'll be sharing the code. I will give you the link at the end of the session, so don't worry. Okay, so just a second. Okay, so let's take this particular red point, okay? What are the 5 nearest neighbors for it? So it's this 1, 2, 3, 4, 5. You can clearly see that all of them are red. So the class for this one will be predicted as red. So here we can see that blue has been misclassified. And then red has also been predicted in the blue region, which is wrong. So let's see why it happened like that. So for this red one, what are the 5 nearest neighbors? So this is blue one, this blue, this blue, this blue, this blue. So all of the neighbors were belonging to the blue color category. So that's the reason, although it should have been in the red category, the model predicted it as blue category based on the values given by the neighbors. Okay, now, we can change how the model behaves based on the value of k we choose. So what is k? K is the number of nearest neighbors. So that is the reason this algorithm is called k nearest neighbors. So the accuracy of the model will change based on the value we choose for the k parameter. So to get the best accuracy, what you can do is, let's say we take the number of neighbors as starting from 1 to 20. So we will loop over all of those k values and compute the accuracy for each of the model using that particular k value. So first we define the k range using the range function, then an empty scores list. And then for k in k range, we define a k neighbors classifier with the number of neighbors as that particular k. Then we fit the model using X-train and Y-train. Then we compute the score using knn.score. Then we append this value into the scores. So even scores will have 20 values because for each value of k, there will be a value of score. We'll initialize the figure and then give the x label as k, give the y-axis label as accuracy. Then we'll do a scatter plot to understand how the accuracy changes when the value of k changes. So the x-axis will be k range, that is the range of k values, y-axis is the scores. And then we will give x tick, so that is like the coordinates for the x-axis as 0, 5, 10, 15, 20. So the multiples of 5. So here if you see accuracy, so accuracy is maximum, so it's 0.6 or 60% accuracy is the maximum. So when is it happening? When k is 1. So when k is 1, this model performs the best. So this is how we analyze the model and choose the different parameters. So this was just for k nearest neighbors, and you can do the same procedure or method for different machine learning models. Let me give you the explanation why for k equals 1, accuracy was the highest. So when k is 1, what actually happened? So for each particular value, the one nearest neighbor to it is contributing. So what will happen? You will be biased or you will memorize the training data because each of the value, each of the neighbor near the data value will be contributing to the value. So the misclassification or the error rate will be very low because each of the neighbor is contributing to the prediction. Okay. Now we will understand how will the accuracy change if we change the training or test split proportion. So initially what we did was, so here in this case, we got 60% accuracy for k is 1. This was the case when 75% of the data was for training, 25% of the data was for testing. Now we'll see if the accuracy will improve or decrease if the proportion will change. So I will define a list called T, which will have values from 0.8 to 0.2. So this is a training set proportion. And then let's say we don't want to deal with neighbors here because so let's take a fixed value, let's say 5. And also 5 is the default in scikit-learn for k neighbors classified. Initialize the figure here for s in t, which means for each of the values in t, initialize the scores list, an empty list. And then what I'm doing here essentially is, so let's say I take 0.8. So this is the training size proportion. Testing set proportion it will be 1 minus 0.8. So that is the reason here test size is 1 minus s, because s is the current value in t. And then we use train test split to split the data accordingly. Here the reason there is for I in range 1 to 1000 is, once I choose a particular test size proportion, I will run this model 1000 times, and then I will take the average of all the accuracies. So this will give you a better understanding of, so you'll get an average sense, okay? So here I'm appending the score in the scores list. Then here, as you can see, I'm plotting S. So you're plotting the graph, training set proportion versus accuracy. So the x-axis value will be S because S is in T and T is the list of training size proportion values. And then the y-axis will be mean of all the 1000 scores we obtained. BO means we need dark blue circles, as you can see below. Let's set the label for X and Y axis. So here we can see that accuracy is maximum when 80% of the data is given for training and then 20% of the data is given for testing. So I've ended it here. So now what you can do is you can choose 80% as the training data, 20% as the testing data, and use K as one. So you will get better than 60%. So because you're taking the best of both the worlds. Okay, this was some introduction. I actually have more algorithms to explain. Just a second. Are you able to see now? Okay, yeah. So first we will take a crime data set. Okay, you can find this online at from the UCI machine learning repository. So I'm defining a function to read in the crime data set or load the data set. Okay, this data set is the name of the file is this com while pred a normalized data, and this data has been separated by commas. Basically, it's a comma separated values list, and then here we say what should you identify as in-year values or missing values. So we say if it's a question mark in the data, identify it as an in-year value. We're reading the table, and then we will remove a few features because this data set is very, very big. So it'll take a lot of time. So just to explain how the whole thing works, I'm just taking few features which were proved to work better based on my understanding and research. Okay, so okay, then from crime.index. So basically we need all the rows, but we need only these columns. So the columns is the, the column with index 5, 6, and then all the columns ranging from 11 to 26, from 32 to 103, and then 145. So we will consider only these columns. These actually turn out to be 88 columns. Then we are using drop NA, that is dropping all the null values. Since our data is huge, here we can drop the null values safely, and then there are very less missing values. X prime is basically we're taking all the rows and then all the columns except for violent crimes per pop, because that is the column we'll be predicting. And then we return the tuple X and Y crime. Okay. And then let me explain first the classification and then regression. Okay, so let's say you don't have data for your machine learning problem. What you can do is you create your own data set for classification regression using scikit-learn. Let me show you how. Uh, you can use the make regression function. So here from sklearn.datasets import make regression, then let's say we need 100 rows, and then we need only one feature, and we need one informative feature, and then bias is 150. So these are all the default values. You just need to consider or learn about number of samples, number of features, and then the reason I'm adding noise here because I want to challenge the model. So I want to see how well it performs when there's noise. And then random state is 0 just for code reproducibility. Let me make a scatter plot of this data. So make regression will return X and Y. So I'm calling it as XR1, that is X regression 1, and then Y regression 1. So let me do the scatter plot. Yeah, here you can see. So we just created this data set on our own. We didn't take it from any other data set. So here we have 100 rows with one feature. So that's the reason there's only one input variable. Okay, now let's say you want to create a complex regression data set where just a linear classifier is not able to predict the regression data. So you can use something called as make fragment one, that is the name of the function. And then let's say you need 100 rows, so number of samples will be 100. And then you need 7 features, then let the random state be 0. So this is just for reproducing it. So we are plotting this again, and let me show you. So let's say if you take a linear model, so it can just fit a straight line here. But for this, a linear model will not be able to do its best because the data is like that, and that's the reason I created this data to explain the limitation of linear regression models. So we need to generate polynomial features if we are using the linear regression itself, or we need to use some non-linear machine learning models. This was for regression. If you want to create your own classification data, you can use make classification function. Let's say you need 100 rows, then you need 2 features. So number of redundant is 0, which means you don't want make classification to build its own features based on the already existing features. Number of informative is 2, that is use both of these features. Then we say number of clusters per class. So we say there should be only one cluster per class. So we don't want more than one cluster. So let me show you the explanation of the code here. Flip y basically means it will randomly predict the target or the y value for 10% of the data. So 0.1 means 10% of the data. Here class step is 5, sorry, 0.5. So this is the class separation. Greater the class separation, easier will it be for the model to separate the data. The default is 1. I'm making it as 0.5 because I want to challenge the model again. I want to see how good it is at classifying data. And then the color of the data should change based on the y value. Okay, let me show the classification data to you. Yeah, so with 2 features, which is yellow and black, this is the binary classification problem. So let's say you want to create a complex classification data set. For that, you can use something called as make blobs. Okay. Yeah, there are going to be more classes like this. Don't worry. I'll be covering a lot of features, concepts, not only in machine learning. I'll also teach you natural language processing, deep learning. I'll be connecting more sessions like this. So please subscribe to my channel. Okay. So here we can use the make blobs. So to create a complex classification data set. Again, 100 rows, 2 features. We say 8 centers. So the data is centered everywhere. So it will be very difficult for a linear model to classify this. Then STD stands for the cluster standard deviation. So I'm giving it as 1.3. So there are few data values which are 1.3 times distant from the mean. So I don't want all of the data to be focused only on the mean. So I want the data to be spread around in all of the 8 centers. That's the reason. Since I want to convert this to be a binary classification problem, what I can do is I'll get the output, right? So I can just do modulo of 2. So this will return 0. So this will return 0 if it's divisible by 2, and it will return 1 if it's an odd number. So that way the output, whatever values you have, it will be converted into 0 and 1. So let me show you how difficult this data set is. So here we can see that one data set, two data set. Yeah, I will share the materials at the end of the session. So don't worry, I will share. Okay, so this is the sample binary classification problem, right? The reason I'm not sharing it now because when I'm teaching, I want you to focus entirely on this. So I don't want you to try out stuff of whatever I've taught you now. So that's the reason I'll be sharing it at the end. That is for the goodness of you. So here you can see that there are 8 centers. So one, two, three, 4 centers in the yellow colors, and then 4 centers with the black colors. So this will be very difficult for the linear model to classify this. Okay, k nearest neighbors is the next model. Okay, let me explain this first. Okay, I had already taught you k nearest neighbors, so I think it's time now. We will continue everything in the next session. So what I want you to do is now, if you want to get access to those cheat sheets and the project ideas which I told you, just a second. Let me explain the project ideas. Let me share my screen here. Um, yeah, here you go. Okay, so this is what I told that I'll be giving you project ideas. Are you able to see now? Okay, the first thing is this is I have the data of us.gov, which partnered with bit.ly. Then the dataset link is here. Don't worry, I'll share all the files. Okay. So using this dataset, so this dataset basically has all the information about what kind of okay, this data set has information about, so as you know, bit.ly is a URL shortening service. This data set has all the details about which user shortened which link and then on which operating system was he, which platform did he use, on which device was he. So it has all this data. So this data is actually in JSON format, which stands for JavaScript Object Notation. So for our analysis and prediction, we need to be able to convert this into a Python dictionary. So there is a Python dictionary method inbuilt. Yeah, don't worry. I will be sharing the recording of this session. It will be uploaded on YouTube. So don't worry. So USA.gov from bit.ly dataset, right? Okay. And then you can count the time zones. That is, this dataset also has a time zone in which a person had shortened the URL. So what you can do is you can find the frequency of the time zone. So from which particular location did most of the people come? Then how did the values vary by, let's say, state, nation, or worldwide? We can also do top 10 time zones and their counts. So there are two methods for this. So there's a hard method and an easy method. So you can just run a loop with an empty dictionary initialized. So if a key is already in the dictionary, then you can increment the value of that key by 1. So I'm saying this is the method to get the count of the time zone. Or if that particular key or the time zone is not in the dictionary, you can set the value of that key to 1, which means you have just initialized a new time zone. Instead of running a loop, in Python, there's a very easy method called default tick. Okay, you can get default tick from the collections module. So you no need to check if keys in the dictionary. What you do is just increment the count of every key by 1. So this default tick is clever to understand whether this is a new key or is this key already in my dictionary. So this is the easy method. And then let's say you need to take the top 10 counts. So what you can do is you can sort in ascending order and then slice off the last 10 entries. Or if you sort in descending order, then you can slice off the first 10 entries. So this is the hard method. You have to sort and then slice off. The easy method is you can use the counter from the collections module, where for that data set, uh, for the dictionary that you have, you can just use the most common function with the argument as 10 because we need just the top 10 counts. Okay. And then how do you deal with missing values? Because if you want to plot a column against another column, or if you want to plot the rows, if there's missing values, you won't be able to plot it. So what you can do is you can categorize the missing values into a different value. So let's say you can replace them and then you can plot them. So these time zones, this data set also has information about which operating system did that person use while shortening. So you can do is whether the person was a Windows user or non-Windows user. So for the given time zone, you can make two different categories. How many used Windows while shortening? How many users didn't use Windows? So let's say they used Mac or Linux. And then you can group these number of Windows and non-Windows users by time zone. Okay, so these are the project ideas, right? I'm explaining what all can be achieved or what are the questions you can solve. So you need not solve this actually because I will be providing you the code for each of these problems here. And then I want you to come up with new questions and then solve that based on what you understood from the solutions of mine given to these problems. Okay. And then the second data set is the movie lens data set. Okay. So it has data about the movie ratings for each film grouped by gender. What you can do is you can find the mean movie ratings for each gender. So just say you take a particular movie, let's say Avengers, what was the average male rating? What was the average female rating? And then you can also find what were the top films among all the female viewers. And then how much rating disagreement or how much difference was there in the rating of the average of all the ratings of the male users and all the average of ratings of the female users, and which movies did men prefer that women didn't rate highly, and most disagreement among viewers, so which movies had very low rating and so on. And then the next data set is the US baby names data set. So what you can do is uh, you can visualize a proportion of babies. So this data set has information about what kind of names were used for babies, and then in which year was it, what was the gender of that particular person. So you can visualize, given a particular name, how did the count of the babies with this particular name change over time. Then you can determine the rank of this. Then you can also determine the most popular names in each year, which had the largest increase or decrease. Then you can analyze trends in the names. So let's say, did people use vowels a lot? And in which position did they use vowels? And how common was it? Or how many consonants did they use? How many vowels did they use? What was the length? Which length is being preferred by parents to name their babies? And what's the overall diversity? Means what kind of different names are parents choosing to name the babies? And what first and last letters are they preferring? Or if you want to go into the advanced level, you can also take into the you can also take into consideration the biblical context. So how is the naming convention changing based on demography? Then you can find the number of male and female births each year. You can plot the popularity of names over time. You can also measure the name diversity. And then what last letters are being chosen to name babies. Okay. Now what I want you to do is I will give you the data set and I want you to solve or write the code to solve each of these questions. And then in my next session, I'll be explaining the solutions for each of these problems. So you can compare how good was your solution, how good was my solution, and if my solution was better, how was it better, what methods did I use to make it better, and so on. Okay. Okay, I'll be sharing these data sets, okay, with all of you. And now what I want you to do is, okay, so I've posted a link in the comments, okay? Just a second. Okay, so what I want you to do is now go to this link. I've asked some questions. If you want to get access to the data sets for this particular problem, then go to this link and fill out your email address. So only those people who fill out this form, I will share the data set with, okay? Go ahead and do it now. I'll be waiting here. Did you understand what to do? If you want to get access to the cheat sheets and then all these data files, you have to go to this link, fill in the email address. Only the people who fill in the email address will be receiving the data set on all the files that I told. Okay, just say yes if you have filled the form there. Okay, so just give me half an hour time. I'll send you all the files. Okay, I mean, there's no reason to hurry up in filling the form. So just fill up the form with the correct details and the details that you feel is the right thing. Yeah, okay. So I see that Yashaswin, Megamark, Karthik, Shivalila, Chiriedim, Venkateshwar Reddy, Megamark 99. Okay, so 1, 2, 3, 4, 5, 6, 7. 7 people have filled it, but I see that there are 17 people watching my thing. So the other 10 people go on and fill that form. Only if you fill the form, you'll get access to the cheat sheets and the data sets I told. Megamark, thanks a lot that you enjoyed. Okay, Rachit filled it, Ditya filled it. Okay, so now that you have filled it, what I will do is I'll share this PDF and the data set, and I've given you the questions as you can see on the screen, right? So I want you to solve or answer all these questions, and then tomorrow I will conduct another live session. I will explain the solutions for these so that you can understand how to deal with projects or how to deal with real world problems. Okay. Yeah. Thank you, Rachit. Thanks for the appreciation. Thank you, Megamark. Thank you for the appreciation. Thank you, Sivalila. Thanks. Thanks a lot. Tomorrow also it will be at 4 p.m. Okay, so one very important thing, tomorrow's live session will be at 4 p.m. and I will be sharing the data set and the questions. So solve those, try as much as you can. If you're not able to get it, don't worry. I'll explain you. I'm here to help you. So tomorrow I'll explain the solutions for the questions. Okay. Yeah, you're most welcome, Ninsoft. You're most welcome, James Shah. I'm new to Python. I need time to go to this level. Okay, so just try it. Okay, Google search like how to solve a particular problem or how can I solve which methods and pandas can I use to solve a problem. Just try everything. Don't worry if you can't. Tomorrow at 4 p.m. I'll conduct a live session. I will give the solution for all of the problems. Don't worry. Yashaswin, the recording of the session, yes, I will share the recording of the session. The session is being recorded. The session will also be uploaded to my YouTube channel. Okay, I will share the link. Don't worry in the WhatsApp group. Okay, so how many of you are beginners here in data science? How many of you are beginners in data science? Okay, if you're not a beginner, beginner, let me know in the comments if you're an intermediate or advanced. Okay, I see Mega Mark, Ditya Prasanna, beginners. Okay, civil. Okay. Mega Mark 1, 2, 3, 4, 5, 6. Okay, 6 people are beginners here. Okay, so don't worry. I will share the cheat sheets, right? So since you have filled the form, I will share the questions on the data set. Try to solve them. I'll also share the cheat sheets. So if you're a beginner, especially, it will be very helpful. It's a gold mine for your data science career. Okay. Okay. Ninsoft has some knowledge on machine learning basics. So Ninsoft, that's very good. Okay. Okay, bye bye for now. Thanks a lot for staying with me till the end. I will give you cheat sheets. And don't forget about tomorrow's live session, which will be at 4 p.m. And I will explain the solutions for the problems. See, I've given you the data set. So this is what will happen when, let's say, you get a job as a data scientist or a machine learning intern or as an intern anywhere. So they'll give you data set and they will give you some questions that you need to solve. So I'm preparing you guys right now from this level itself to understand how to solve problems using data set. Okay. So don't forget to attend my live session tomorrow at sorry 5 p.m. 5 p.m. Okay. Tomorrow's live session will be at 5 p.m. I will explain the solutions to problems. Okay, so and also one more thing, it takes a lot of effort and time for me to produce high quality content. So if you haven't subscribed to my channel, please subscribe to my channel because let our community grow and you people subscribers motivate me a lot to produce high quality content for the betterment of your career. Also, if you feel the live sessions and the things I'm doing for the data science community is helpful, please recommend my channel and advise them to watch my live sessions to your friends and colleagues. That will really motivate me and help me stay stronger. Thanks a lot. Yeah, so if you have filled the form, you will get access to the data sets. So just give me some half an hour time. To all those people, I'll send an email, okay, right now. Okay, thanks a lot. Bye bye. Hope you're doing good. Bye bye. Thanks a lot. Okay, thanks a lot. Okay. Okay, the main thing I wanted to take away from this session is don't worry if you're a beginner in data science. Okay, I'll help you start from the scratch, then slowly build up on the advanced and intermediate skills, which will help you to reach your big goal of being a data scientist in a big company. Okay, so don't worry. Okay, thanks a lot. Bye bye. Goodbye.